So again, we're dealing with standard position trig. So what's really important is the position, the location of the point, and we can describe it with x and y coordinates, or which relate to sine and cos ratios, or with an angle measured from the initial arm. We measure from 0 degrees. Okay, so this problem here, we've been given the position as a coordinate. And since it's given as a coordinate, -3, +8, maybe somewhere about there, I'm going to put it on the circle. I'm going to sketch in my reference triangle here. So -3, +8. Since we have two sides of this triangle, we want to keep everything in exact values. Now, when we do the angle, we're going to have to use a decimal, but for any of the ratio sides, we use exact values. So the first thing we should figure out here is the radius. So 64 plus 9 is 73. So I get square root 73, and I leave it as square root 73. Okay. Now, we can work out the approximate value, but again, those approximate values are ones that we're not going to use. Okay. We want to stick with, although they're perfectly fine, it's good to know the numerical values of some of these things. Okay. We want to try to apply things in exact values. So it's going to be 8.54 approximately. But what we want to do is make sure that we're using this value when we're doing any of our work. So there it is. So I want to figure out the trig ratios. So sine ratio is going to be the opposite, which is really y. So sine goes with y. It's going to be 8 over square root 73. Okay, now that does have a decimal equivalent. Okay, but again, we're going to stick with the 8 root 73. So if I do 8 divided by square root 73, okay, I get 0.936. So 0.936. So that tells me that the opposite to radius is this side is about 94% the length of the hypotenuse there. Okay, so the cosine, we want to use exact values. So cosine goes with x, so it's going to be -3, not 3, because remember we're dealing with positioning. Okay, the position is going to be -3, or 3 to the left, 8 up. -3 over root 73, and if we want to work out the approximate decimal for that, we go -3 divided by root 73, and we get about -0.315. Sorry, 351. Okay, so this is going to be about 35% the length of that radius. The tan ratio is my slope, so I know it's going in the negative direction. And if I work out the decimal for that, that's 2.66. I'm going to round that to 7. Okay, so determining ratios from the point, we're going to first of all solve the triangle. For the third side. And we keep exact values. Okay, so what that means then is we're going to use these values, these exact values, instead of the decimal values. Okay, so that's the first thing. We solve for the third side. In this case, it was a hypotenuse. And then we use the exact values in a ratio to write the ratio. Okay, and we do this in fraction form when possible. Okay, so it's important that we try to stick with this. These numerically are nothing wrong with them numerically, but what we really want to start working on is using these exact values. So when do we need our calculators to do standard position problems? So it's when we want to go from angle 1:2 ratio, or if we want to go in the other direction. Okay, this involves calculator. Okay, we need to be able to go between the two. Okay, so we need to be able to go between the ratio form and the angle form using our calculator, except for those special value triangles, those special value angles that we did last day.